The definition of the derivative is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So before we get started, let's come up with a function that we can take a derivative of as an example. So example number 1. So for our function, let's do something not too challenging so that we can, kind of remember how to do this, but something that'll give us a good idea of how this works. So the function that I'm going to do is 14 plus 3x plus 7x squared. So before we actually do the derivative with using the definition of the derivative, let's just use the shortcut so that we can verify it later. So using the shortcut, we know that the derivative of this function is 0 because the derivative of 14 is 0, plus 3 because that's the derivative of 3x, and then plus 14x because that's the derivative of 7x squared. So now that we have this derivative, let's go on and use the definition to prove that this is the derivative. So according to this equation right here, what we need to do is, taking the original function, we need to first set it equal to f prime of x equals, so now the limit as h approaches 0 of, and now for the first step, every time you see an x in the original function, like here and here, you're going to plug in an x plus h instead of an x. So for the first part, that's going to be 14 plus 3x plus h, because there's an x there. So we plugged in x plus h, plus 7x plus h squared, because there's an x there. So we put in x plus h squared, all over h. Now that we have that, oh, and before we move on, I need to take away the original function because that's the f of x. So that is 14 plus 3x plus 7x squared. Let's put that in parentheses so that we're not tripped up later. So this is just this with this function. So now for the next part, what we want to do is kind of expand these out so that we can simplify them later. So let's go ahead and do that. So to expand this first part, it's 14 plus 3x plus 3h plus 7x squared plus 14xh plus 7h squared minus 14 minus 3x minus 7x squared all over h. Now that we've expanded these terms, let's cancel out some of the terms that we have to make our lives easier. So f prime of x equals the limit as h approaches 0 of, so here we have a 3x and a negative 3x, so let's go ahead and cancel those out because that's going to equal 0. We have a 14 and a negative 14, so cancel those out. And we have a 7x squared and negative 7x squared, so we're going to cancel those out. And that leaves us with 3h plus 14xh plus 7h squared over h. So 3h plus 14xh plus 7h squared over h. So now, because we have an h in the denominator, we can kind of simplify this numerator over here. Let's cross out this h, and this h, and this h, and one h over here. And that's going to leave us with f prime of x equals the limit as h approaches 0 of 3 plus 14x plus 7h. So now that we've completely simplified this monstrosity into this, we can go ahead and substitute a 0 in for any h's in here. So the only h we have is this one. So that's going to leave us with the derivative f prime of x equals 3 plus 14x plus 7 times 0, which is f prime of x equals 3 plus 14x. Like that. So if you recall, this is the same thing that we got up here when we used the shortcut, 3 plus 14x. So the definition of the derivative does indeed work. Work through an example problem. Let's go ahead and work on an AP problem from an AP test. So this is a problem on one of the AP tests that I found, and we're going to be using the definition to solve for this. So let's go ahead and write this down. F prime of x equals 3x minus 2 over 2x plus 3. So we want to find the derivative of that. And let's go ahead and write down the definition so that we don't get lost. So that's the limit of h approaches 0 of f of x plus h minus f of x over h. So now that we have this, let's go ahead and plug this into this. So f prime of x equals 3x plus h minus 2 over 2x plus h plus 3 minus 3x minus 2 over 2x plus 3 all over h. We're taking the limit of that. So what I did here was this step right here represents the f of x plus h, where I plugged in an x plus h in place of every x, and this represents the original function all over h. So now that we've got that framework, let's go ahead and kind of expand these out so that we have an easier time later. So f prime of x equals the limit of 3x plus 3h minus 2 and 2x plus 2h plus 6 plus 3 minus 3x minus 2 over 2x plus 3 over h. So now that we've expanded these out, we need to be able to subtract these, and to do that we need to have a common denominator. So we're going to multiply each side by the other's denominator. So right here it's going to be 3x plus 3h minus 2 times 2x plus 3. And then we're going to keep one denominator. And the numerator on the left will be 3x minus 2 times 2x plus 2h plus 3. This is all over h still. Alright, now the next step is to multiply these out right here, FOIL them I guess, and right here. So f prime of x equals the limit as h approaches infinity, or 0, sorry. So then it's 6x squared plus 6x h minus 4x plus 9x plus 9h minus 6 minus 6x squared plus 6xh plus 9x minus 4x minus 4h minus 6. Kind of ran out of space at the end, but I guess we got the idea. This is all over 2x plus h plus 3 times 2x plus 3, and that is all over h. Now the next thing we're going to want to do is cancel out all of the like terms, like here, 6x squared and negative 6x squared will cancel. This will cancel. The minus 4x and the positive 4x will cancel. 9x will cancel with the, it won't cancel, but it'll reduce. And then the negative 6 and the negative 6. So what we're going to be left with, because we have 9h and 4h, is 13h on the top. So f prime of x equals the limit as h approaches 0 of 13h. That's going to be on top of 4x squared plus 4xh plus 6x plus 6h plus 9. Now what we need to do is kind of simplify this out. And a good thing to do here is everywhere you have a common term, just add it. All right, now the next step is to multiply these out right here, FOIL them, I guess, and right here. So f prime of x equals the limit as h approaches infinity, or 0, sorry. So then it's 6x squared plus 6xh minus 4x plus 9x plus 9h minus 6 minus 6x squared plus 6xh plus 9x minus 4x minus 4h minus 6. Kind of ran out of space at the end, but I guess we got the idea. This is all over 2x plus 2h plus 3 times 2x plus 3, and that is all over h. Now the next thing we're going to want to do is cancel out all of the like terms, like here, 6x squared and negative 6x squared will cancel. This will cancel. The minus 4x and the positive 4x will cancel. 9x will cancel with the, it won't cancel, but it'll reduce. And then the negative 6 and the negative 6. So now what we're going to be left with is f prime of x equals the limit as h approaches 0 of 13h over 4x squared plus 4xh plus 12x plus 6h plus 9. So now what we can go ahead and do is kind of simplify that. So f prime of x equals the limit as h approaches 0 of 13 over 4x squared plus 12x plus 9. And now we can go ahead and finally take the limit now that everything is simplified. And there are no h's in this in the remaining problem, so this is the limit itself. So the derivative f prime of x equals 13 over 4x squared plus 12x plus 9. So the AP test problem has the answers with denominators as simplified. So let's go ahead and simplify the denominator. So the derivative is going to be 13 over 2x plus 3 squared. And let's take a look at those answers. And it is answer D.